Okay, in the first tutorial on finding all zeros given a real zero, I mentioned that we would handle the process a little differently if we were given an imaginary zero. And so that's going to come up in this tutorial. In this case, I'm given 2 minus I as my zero. So it's not real. So I'm going to handle this a little differently. I think you're going to find these to be a little bit more difficult than if you're given a real zero. Now, in this case, the very first thing that we want to do is we want to reference the conjugate pairs theorem, which tells us that if a plus bi is a zero, so if a plus bi is a zero, a minus bi must also be a zero. Again, that's the conjugate pairs theorem. It would be the same thing with a radical as well. So, for example, if 1 plus the square root of 2 is a zero, 1 minus the square root of 2 would also have to be a zero. So you have to remember that when you have an imaginary zero. If you don't remember that, you're kind of going to be wandering aimlessly at this point. So I know that 2 minus I is a zero, which means that 2 plus I is a zero. So I'm going to write those. And I'm going to write them one on top of the other. So 2 minus I and 2 plus I. Now, I tell my students to use a little shortcut for creating the polynomial that would come about from 2 minus I and 2 plus I. So let me walk you through that very, very briefly. So I have this little shortcut that I say x squared minus the sum plus the product. Let me write that here. So I would have x squared minus the sum of the zeros times x plus the product of the zeros. Okay, so if I can add the zeros, that's going to give me the middle term, and if I can multiply the zeros, that's going to give me the last term, or the constant term. So I'm going to take a look at 2 minus I and 2 plus I, and the first thing that I'm going to do is I'm going to add them. And again, I put them one on top of the other because then it makes it a little easier to add it, I think. So if I add these, I'm going to get 4, and the i's cancel. So my sum is 4. So if I were to start my polynomial, I'm going to get x squared minus 4x. Sorry about that, let me fix that. And again, the reason why it's minus is because it's saying x squared minus the sum. So since the sum was positive 4, I have to use the opposite sign. Alright, well now I have to do the product. So let's do the product here. If I have 2 minus I and 2 plus I, and again I'm going to write them one on top of the other because it always makes it easier if you're lining them one on top of the other. Now they're conjugates, so the middle term is going to cancel, so I can multiply straight down. So I get 4 minus I squared. Now hopefully you remember that I squared is negative 1, which would make this 4 plus 1, which gives me 5. Therefore, my polynomial is x squared minus 4x plus 5. So again, x squared minus the sum of the zeros times x plus the product of the zeros. Now, what was the point in finding that? Well, the reason why I found that is now I'm going to use, in this case, long division to pull this polynomial out of the polynomial that was given to me. I can't use synthetic division because that polynomial doesn't match my rule for synthetic division, so I'm forced to use long division. Okay? Now, it always sounds like long division is going to be kind of a pain, but it's really not going to be that bad in this case. And it never will be when I'm using this technique. So, I'm going to take the polynomial that I just created, which is x squared minus 4x plus 5, and I'm going to divide with the original polynomial, which in this case is x to the third, minus 7x squared plus 17x minus 15. Now the reason why it's not going to be that bad is I know the remainder is going to be 0. And remember, if I go back, if something is a 0 of a function, that means that the remainder will be 0. So I know the remainder is going to be 0. And I'm only looking for one more factor. So I'm really only going to have to do this technique twice in terms of how many steps I'm going to have to take here. So the very first thing that I'm going to do in long division is I'm going to look at the first terms, and I'm going to ask myself, okay, What do I have to multiply x squared by to get x to the third? What do I have to multiply x squared by to get x to the third? The answer to that would be just x. And I'm going to line it above its like term. And now I'm going to take the x and multiply by all three pieces out in front. So x times x squared is x to the third. X times negative 4x is negative 4x squared. Once again, sorry about that. And then x times 5 is 5x. Now you always have to be careful. When we are going vertical on long division, I must subtract. So always be careful with your signs when you're doing this. So the x cubes cancel. Negative 7x, this would become plus 4x squared, gives me negative 3x squared. And then I have 17 minus 5, gives me 12. And then I bring down the 15. Now I repeat the process. What do I need to multiply x by to get negative 3x squared? Well, the answer to that would be negative 3. Now, I'm going to stop here. And the reason I'm going to stop here is because I already know that the remainder is 0. So I'm not going to have anything else. That factor's done. However, if you're not sure if you've done your long division right, you want to keep going to see if the remainder is 0, because it should be. And if it's not, that means you've done something wrong. So the factor that was hanging out there that I needed to find in this case was x minus 3. Well, what I have to do with that factor now is set it equal to 0. So I get x minus 3 equals 0. So the third and final 0 that I was looking for is x equals 3. Again, let's revisit. How did I know that there were 3 zeros? Well, fundamental theorem of algebra, whatever the degree is, represents the number of zeros that I have. I already knew that 2 plus I and 2 minus I were zeros. And now I have found that x equals 3 is the third and final 0. So to wrap this up, my answers are going to be 2 plus I, 2 minus I, and 3. And that's it. Now, as always, to check, and you should always do this, go back and make sure that you're right. So I'm going to go back to my graphing calculator here, and I'm going to put in this original equation, which was x to the third minus 7x squared plus 17x minus 15. And remember, zeros occur